Good morning students. Today we will discuss about VI characteristics of PN junction diode or volt ampere characteristics of PN junction diode. Earlier classes we have discussed about what is forward bias and what is reverse bias. Different biasing techniques in PN junction diode. So in forward bias we have discussed about voltage ampere characteristics, and in reverse bias also we have discussed about volt ampere characteristics of PN junction diode. If we combine these two, we will get the VI characteristics of PN junction diode. So when we go for characteristics of PN junction diode, when we consider forward bias, so forward bias, forward voltage is taken on x-axis and forward current on y-axis. So what is meant by forward bias? So see here, if the circuit, here if it is PN junction, if I give forward bias, what is meant by forward bias? If the positive terminal of the battery is connected to P-type and negative terminal of the battery is connected to N-type, we call it as forward bias. Now what are the majority charge carriers in P-type? Holes, and majority charge carriers in N-type are electrons. Holes carry positive charge. So here positive terminal is connected to P-type. So positive, they repel each other and these holes will be moving towards junction. And these negative repel and these electrons will be moving towards the junction. So there are charge carriers which are created at the junction. What happens is the width of the potential barrier decreases. The width of the potential barrier decreases, and after some time the potential barrier will disappear. Means current will be flowing through the circuit. So see here, for junction, see here, for germanium and silicon, there is certain contact potential or junction potential. For germanium it is 0.3 volts. And for silicon it is 0.7 volts. So after junction potential, after this contact potential, what happens is, as the forward voltage increases, as the voltage increases, current also increases in forward bias. So this current is due to majority charge carriers. This is due to flow of majority charge carriers. So this current is measured in milliamperes. It is measured in milliamperes. For silicon, contact potential is 0.7 volts. Means after 0.7 volts, as the voltage increases, current also increases. So as the voltage increases, current also increases. Now this is the case for forward bias. Now, so what is this potential? We call it as, we can call this potential as cutoff voltage or otherwise contact potential. Next, if we go for, see here, we will see this forward bias. So what is forward bias? We can study under forward bias when positive terminal of the battery is connected to P-type semiconductor and negative terminal of the battery is connected to N-type semiconductor. This we call it as forward bias. So if I study, means in words, if I study forward bias characteristics, as the forward voltage is increased, so for forward voltage less than V0, what happens? For VF, here forward voltage, see here VF, forward voltage less than cutoff voltage V0. What happens? There is no flow of current, because the potential barrier prevents the flow of electrons from N region to P region. So depletion region, see here what happens? There is no flow of current. But if forward voltage is greater than threshold voltage, means cutoff voltage, what happens? Electrons can move freely from N region to P region and holes can move freely from P region to N region. So there is flow of current. So this we call it as forward current, which is taken in milliamperes. So this cutoff voltage for germanium is 0.3 volts and for silicon is 0.7 volts. So this is about forward bias characteristics. Now if we move for reverse bias, see here reverse bias, we know that when we draw a reverse bias circuit, see here this is the p-type semiconductor and this is the n-type semiconductor. What is meant by reverse bias? Here p-type should be connected to negative terminal of the battery and n-type should be connected to positive terminal of the battery. So if we connect like this, what happens here? These are the majority charge carriers, holes. Here electrons. So here holes carry, here positive terminal is given with, p-type is given with negative terminal and n-type is given with positive terminal. So here holes carry positive charge. Negative positive attract each other. So these holes will be moving away from the junction. And here also electrons carry negative charge and terminal is positive. So these electrons will be moving towards the terminal. So due to flow of these charge carriers towards the terminals, what happens? Potential barrier increases. Here potential barrier increases, means there is no flow of current. There is no flow of current due to majority charge carriers. Due to majority charge carriers, there is no flow of current. But what are the minority charge carriers? In p-type, minority charge carriers are electrons. In n-type, minority charge carriers are holes. So here negative, negative, what happens? They repel. So they move towards junction. And these holes, here positive, positive repel and they move towards junction. Means there is small current due to minority charge carriers. So what is this? There is small current due to minority charge carriers. There is no current due to majority. In reverse bias there is small current due to minority charge carriers. We call it as reverse saturation current. So this small current whatever we are showing, this is due to minority charge carriers. That's why current we have taken in terms of, it is very small, we have taken in terms of microamperes. Now what happens is, here after when you give large reverse bias, what happens is breakdown takes place. Breakdown takes place means plenty of free electrons is available. So how these free electrons are available, we will discuss in the next class, because this is due to two types of breakdown mechanisms. One is Zener breakdown and avalanche breakdown, that we can discuss clearly in the next classes. Okay. So due to breakdown, what happens is, at large reverse bias, breakdown means plenty of free electrons are available. Means when free electrons are moving, what happens? Current increases rapidly. This current will be increasing rapidly. Okay. So here current will be increasing rapidly without any change in voltage. Means you cannot control this current with voltage. This we call it as breakdown voltage. So this is about reverse bias characteristics. So what we have discussed, here in reverse bias there is no current due to majority charge carriers. There is a small current due to minority charge carriers. That current we call it as reverse saturation current. At large reverse bias, what happens? Breakdown occurs. Breakdown means there will be plenty of free electrons flowing without any change in voltage. So if I see here, if we see the nodes of reverse bias, so see here, what is reverse bias? The negative terminal of the battery, it should be connected to p-type, and positive terminal of the battery should be connected to n-type. Then we call it as reverse bias. So see here there is no current flow due to majority charge carriers, but there is a flow of current due to minority charge carriers. Due to this diffusion of minority charge carriers, there is current, a small current, which is called as reverse saturation current. Next, see here Next, see here, for large applied reverse bias, if you apply large reverse bias, what happens? The free electrons will be moving from N type to P type and they will be colliding with, means this process we will discuss in next class. Okay, so they will be colliding with crystal ions and they move electrons. So they take out electrons from the parent atoms. So this large number of free electrons will get bunch of free electrons which are flowing without any change in voltage. This we call it as, that voltage we call it as breakdown voltage. So this is about forward bias characteristics and reverse bias characteristics. Okay. Thank you.